trust you to drive like mom drives.
Is this it?
My parents are taught driving. You drive. You drive the way.
Yeah.
Okay, so now still I don't have my PDF, so I better talk about, what is that? Talk about next Wednesday. Next Wednesday, please listen to me. I said next Wednesday, not Monday or any other.
What?
Really?
I just don't want to wake up. I'm so sorry. It's not you. It's me. It's me.
That was not nice. You know that.
I was happy I got it right.
Really? I didn't get what she said. I was just
Okay, so next Wednesday we don't have class.
Monday? You don't have class on Mondays?
You don't have class on Monday?
I guess.
Wednesday. Why?
It's not you.
Okay, so do you have any question for me? Okay, today we are going to talk about chapter 12, random variables, probability. We already actually saw the concept of probability in chapter 3 when we were talking about probability of z less than something, z greater than something, probability of z between two values. That kind of probability was probability of normal distribution. And now in this chapter, mostly we are going to talk about the probability of discrete data set. Like if we toss a coin, you know, there are just two outcomes for tossing a coin, correct? What are those outcomes?
Heads or tails?
Exactly. So this is a kind of discrete outcome. Or when we roll a die, the outcomes, the possible outcomes are either 1, 2, 3, 4, up to 6. As you see, these are separated numbers like discrete data set. Oh, well, we don't have the notes here. Okay, so probability, the concept of probability came from a long time ago when they were talking about gambling, and they wanted to see how, what is the chances of, for example, winning a game, and they mostly were using, coin. And they were saying, okay, let's see, what is the chance of, observing head, what is the chance of observing tail, and mostly they were talking about, okay, observing head means we are winning the game. And then they use die, they use different method. And after many times they understood that there is kind of pattern behind throwing or rolling a die or tossing a coin, and they went through some trials to see if there is really a pattern behind rolling a die and tossing a coin. What they did was that they tried to toss a coin many times over and over and over, and every time when they were tossing a coin, they were looking at the outcome and they were writing down the outcome. For example, out of 1,000 times they were tossing a coin, they understood almost 500 times they are observing head, and the other 500 times they were observing tail. So the approximate number, we're giving them a kind of result, like 500 out of 1,000 is almost half, right? And they understood, yes, if they continue tossing a coin over and over and over, they will see a pattern behind that. So concept of probability started from that time. They understood, yes, probability or the outcome of random variables can be uncertain, but if they continue that for a long trial, long time, there will be some predictable outcome behind that. So today we want to talk about probability. And oh, I no one knows that? I forgot that there should be something here to close this one. Okay, so when I said 500 out of 1000, that is like finding the percentage. So what you do, the number of outcome you observe over the total outcome, okay? Kind of concept of probabilities, same as finding the percentage. Finding, you know, whatever you observe out of the overall outcome. Okay, so there are some definitions. Let's talk about this definition. Oh, these are the trial they had for in different time era. Like they tossed a coin 4,040 times, and out of this 4,040 times, they understood and they wrote down 2,048 times you're observing it. Divide this number by 4,040, you will get almost half, correct? So they understood probability or, you know, pattern of observing it will be almost 50% of the time or half of the time. And then they did another trial with more, you know, time tossing a coin, 24,000. And then they observed 12,000 12 times. They observed 10. And then divide this number by total number, which was 24,000, you will get again 50%. You see that? So every time they increase the trial, still they are seeing the pattern. Okay, so we already are familiar with the concept of randomness. We used table B before, correct? And we know how to choose random numbers using, for example, table B. There are different ways like computer or random waves also giving us random numbers. But the thing is that some of them are maybe difficult, some of them are as easy as table B you saw already. So we know what is random. It says they call a phenomenon random if individual outcomes are uncertain. But as I said, there is a nonetheless a regular distribution or pattern of outcome in a large number of repetitions, like large number of trials or, you know, tossing the coin. And then another concept is probability. It says probability of any outcome of a random phenomenon is the proportion of times the outcome would occur in a very long series of repetition. As you see, I'm repeating this over and over, long number of trials, long number of repetition. So if you want to find the probability, you should try something in over and over, in long, you know, kind of a period of time. Okay, so now we are going to start with some simple questions to find probability. Like how we can find the probability if we roll a dice, just one dice, or if we toss just one coin. So we start with tossing one coin. Okay, so there are some concepts you should know. One of them is sample space. Sample space. We show sample space with S. To be able to find a probability, this is the first step. So what is sample space? Sample space is the set of all possible outcomes of a study. So if we toss a coin, what are the possible outcomes you will observe? Toss just one coin.
Head and tail.
Head and tail, right? Either you will see head or you will see tail. There are just two possible outcomes. When I said set, means you will write it down in this way. I am showing sample space with S. Set, we use this kind of curly bracket. And then we write down all the possible outcomes. I'm showing head with H, I'm showing tail with T. So we call this sample space. Again, what is sample space? Sample space is set of all possible outcome in a study. And this is the first step to find the probability. Okay? And we show sample space with S. The other step is this. What is question in your mind? You want to see what is the probability of observing head. So this will be the event for you. The question is in your mind. Whatever you want to find is the event. We show event with A or B or C or any other letters, and this event will be subset of this sample space. If you're thinking about how many times I observe head and what is the probability of head, you can create an event for yourself. Show that with A and say, we want to know what is the probability of observing head out of this sample space. So as you see, head is the subset of this sample space. What's the meaning of a subset? Means it's a part of this, correct? And I can say, someone will say, I have this question, I want to see what's the probability of observing tail. They can create this event B and say, okay, I want to see tail. And then someone will say, okay, so I want to create an event of either observing head or observing tail. This will be also a subset of sample space. It's exactly equal to sample space, but it can be subset of sample space because it's kind of coming from sample space, correct? So how to find the probability of these events? So we call A, B, C event, we call S sample space. We say probability of event A, so he represents probability, in parentheses we have our event, equal to, there is a fraction. Number of times we see the certain outcome in our event. So event goes here. And then here, the number of outcomes in sample space. How many outcomes we have in sample space?
2.
Just 2 of them, right? So here we will have 2. For event A, how many outcomes we have?
1.
Just 1, right? So number of outcome in our event goes on numerator to the total number of outcome in sample space. So what is the probability of observing event A?
1.5.
Half, right? Or 50% of the time. You can convert that to percentage, you can show it like decimal, or you can keep it as a fraction. So probability of observing head when we toss a coin just one time is half. What is the probability of observing B? We know that the number of outcome in sample space is 2, right? What is that?
One.
Right? So as you see, the probability of observing tail is half, correct? So the thing they were doing with repetition, tossing a coin over and over and over, and they reached 50% of the time, they are observing head or tail. We just easily found that with this relation or this formula of probability. So formula for probability says the number of outcome in event divided by the total number of outcome in sample space. So what's the probability of observing C? 2 over 2 is 1. Means 100% of the time we will observe either head or tail, correct? So the probability is 1. Okay. Do you have any question about this? So this is the kind of simplest question about probability. So tossing just a coin one time. So now we want to talk about tossing a coin tossing actually 2 coins. So we should have a sample space, and we can ask some question and create some event. Do you have any question? Any question? Okay. So we have 2 coins. We will toss these 2 coins both together. Okay? So on one of them, I can observe head, right? At the same time, on the other one, I can observe head, right? This is one of outcome. Both of them can show head. So the first outcome will be HH. This is for the first coin. This is for the second coin. Correct? And then again, what is the other possibility? So the first coin can be head. The second coin can be tail, right? So I can write down head for the first one, tail for the second one. What about observing tail on the first coin? So maybe we toss these 2 coins together. We observe tail on the first one, and again we observe tail on the second one, right? And then there is one more. Tail, head, right? Tail on the first one and head on the second one. So there are just these 4 outcomes, right? Do you think there is more? No, there is not anymore. Correct? So let's say the event can be observing the same thing on both of coins. Observing the same thing on both of coins means head on the first one, head on the second one, right? H, H. And then observing both the same thing, tail, tail. I want to find the probability of observing the same things on both of these coins. Can you just by looking at these 2 sample space and event tell me what is the probability of observing A? What is that? 2 over 4 is Exactly. So probability of observing A is 2/4, which is 1/2. Because 2 is the number of outcome we see in our event, right? 4 is the number of outcome we observe in sample space. Okay? And then let's say event B. Observing head on the, actually no, let's say observing at least one tail on either of these coins. Observing at least a tail on either of these coins. Look at the sample space. Which one of these outcome give us at least 3 of them, right? Do you see that? So what are those? HT, T, 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 H. Observing at least one tail on either of them. What is the probability of event B? 3/4, exactly. 75% of the time, right? 75% of time, or 0.75, right? 75, huh? Okay. Then any other events, as long as those events are subset of sample space, you can find the probability of any event, right? Do you have any question now? Do you understand this one? Sure?
Yes.
Okay, next question. Next question will be about, let me give you an idea about, for example, what happens if we have 3 coins. 3 coins and we want to toss 3 of them all together. We should create a sample space, right?
Yes.
Say 3 coins. So I don't want to write it down all, but I want to just give you an idea so you can complete this. So what can I see? If I, these are the easiest one, huh? Tail, tail, tail. Okay? What is that? Head, tail, tail. It can be more than this, right? So you can write down all of them. Just, you should find a kind of pattern, and you should not have any repetitive outcome, okay? So you are able to write down all the sample space, and if you have any question, like what is the probability of observing this event, that event, subset of sample space, you can answer any probability questions, right? Okay. So now we want to roll just one die. There are 6 outcomes for that, right? Please write down sample space for rolling just one die. So 2 dice, 1 die, right? So if you have just one of them, we call that die. So we want to write down a sample space for rolling one die. The sample space is 1, 2, 3, 6. Okay. What is the, okay, write down the event of observing even numbers. What are those? 2, 4, 6. What is the probability of observing event A? 3 over 6, which is? Right?
Oh, yeah.
What is the probability of observing 6? Hmm? 1/6, exactly. Correct? Then you can convert that to a percentage and say there is this much percent chance that we observe 6, right? Any question? 1 over 2. 1 over 2, correct? So, what is the probability of observing any number greater than or equal to 4? Greater than or equal to 4. 4, 5, 6. And the probability is? Oh, sorry. 3 over 6, which is half. Greater than equal to 4. If I was saying greater than 4, you wouldn't include 4, right? Okay, so now you are ready for this one. We want to roll 2 dice. Okay, we have 2 dice. We will roll both of them together. On this one, we can see any numbers from 1 to 6. On this one also, we can observe any number from 1 to 6, right? We can observe 1 on this one and 1 on this other one. 1 on this one, 2 on the other one, right? 1 on this one, 3, 4, 5, 6. And again, we can see 2 on this one and any number from 1 to 6 on the other one, right? So we can write down a sample space, all possible outcomes, right? Either we can write it down like 1, 1, 1, 2, 1, 3, 1, 4. So this is not 11, 12. You know that this first number is for the first die. The second number is for the second die, right? And then we can write down 2, 1, 2, 2, 3, 1, up to, and then 6, 6 is the last one, right? There are many numbers. So the sample space will have 6 multiply 6 because this represents the first die. There are 6 outcomes, multiplies to the other 6 outcomes on the other die. So total of 36 outcomes we can see. And these are all the possible outcomes. And this is our sample space, right? Here is a picture of rolling 2 dice. On the first one, 1. On the second one, 1. And up to 6, 6. Okay, so now fast. What is the probability of observing 6, 6? 1 out of 36, exactly, right? So now you understood the concept of probability, and you can find any probability as long as you have the sample space, as long as you know how many overall outcomes you have, correct? Now, write down the event of observing even number on the first die. Even number just on the first die. So the first die is just even number, the second die can be any number, right? So tell me. 2. No, we want to write down all of them. 2, 1, 2, 2, 2, 3, up to 2, 6, right? Then 4, 1, 4, 2, up to 4, 6, right? 2, 4, and then 6, 1, 6, 2, up to 6, 6. How many outcomes we have in this? 18. Exactly. Because each of these rows shows us 6 of them, right? 6 multiplied 3 is 18 of them. So what is the probability of observing A? 18 over 36, which is, right? Okay? So we have 6 of them here, 6 of them here, 6 of them here.
Yeah, when I was counting, I lost it to 15, I was like 12.
You were missing one of them. Any questions so far? So, in this note, we have something. They talk about how gamblers talk about rolling 2 dice. They mostly are kind of interested in finding the summation of these 2 dice. For example, they will say, what is the probability of observing 5? So what that means summation of both these numbers, like, which one, this one? 2, 3. Summation of 2 and 3 gives us 5. So they talk about, probability and the event in that way. They say, what is the, for example, probability of observing 12? Observing 12.
1 out of 36.
1 out of 36, because this is the only time you observe 12. Like summation of 2 dice are 12, right? So 1 out of 36, okay? And then that question is saying summation is 5. 1, 4 gives us 5. And again, 4, 1. And definitely you should know there's a difference between this outcome and this outcome, right? This outcome says the first die is 1. This one says the first die is 4, okay? So these are all the possible outcomes of observing 5. Means summation of both of these dice is 5. And then what is the probability of observing A here? This A. What's the probability of observing A? Observing A. Probability of A is 4 out of 4 out of 36 is 1 over 9. Exactly. Okay. Let's see what else. This is the formula for probability on this page. You see that? And then this is the way they are talking about the probability. So these are all the summations. They are talking about 2 summation is 2, summation is 3, summation is 4. So what is the probability of observing summation 2?
1.
Probability. 1 over 36. So summation is 2 means we observe 1 on one die, 1 on the other die, right? Summation becomes 2. And this is the only outcome. 1, 1 is the only outcome over 36 outcomes, right? So probability of observing summation 2 is 1 over 36, okay? So, okay, let's talk about probability rules. As we saw here, so far all the probabilities we found are a number number between 0 and 1. They were like fractions, but if you convert that to percentage, all the percentage are the number between 0 and 1. So this is the first fact about probability. Probability is a number always between 0 and 1. If the probability is 0, we say there is no chance of observing that event. Correct? If probability is 1, means 100% of the time we see that event. So the first probability rule says probability of A means any event. You can write down B, C, D, anything. Okay, probability of any event is a number between 0 and 1. Means it's a decimal between 0 and 1. So if you are finding probability and the number is negative, the probability you found is wrong. Okay? If a probability you found is a number bigger than 1, still the probability you found is wrong. Your calculation were wrong at some point. Okay? So, probability is a number between 0 and 1. It can be 0, and if we see 0, means there is no chance of observing that event. If we see 1, means for sure we observe that event. Now, probability of observing sample space. Did you see that we had a sample space of head and tail? And then event C, I said, what is the probability of observing either of them? And then probability of C became 2 over 2 equal 1. C was sample space itself, right? And it proves that probability of observing sample space itself is always equal to 1. And this is the other probability rule. Probability of observing sample space is always equal to 1. Let me have this example again. Head, tail, head, head, tail, tail, tail. Okay. Let's say A is an event of observing at least one tail. So we saw this before, right? Yes. Observing at least one tail. What is the probability of A? 3 over 4. Correct? 3 over 4. Right? Let's say this one is, let's say now I want to find the probability of not observing at least one tail. Not observing at least one tail. The only is HH, right? This probability is equal to 1 over 4. This one is not observing event A, right? Because as I said, not observing at least one tail. Is that right? So it's kind of opposite of A. Or if this is an event of observing A, this is the event of not observing A. There's a relation between these two. This was 3/4, this is 1/4. Addition of these two gives us 1. Or if you didn't know this probability, you could say, okay, probability of observing A is 3/4. Probability of not observing A will be 1 minus 3/4, because now you know probability of sample space is 1, right? 1 minus the probability you already observed, correct? This is another probability rule. Says probability of not observing any event, let's say event A, B, C, anything, you can call that anything, is equal to 1 minus probability of observing that event. We chose A, so this will be A. Okay? So one more question about this rule. Let's say B is the event of observing both of these outcomes are the same, like H, tail, tail. So what is the probability of B? 2/4, which is 1/2, right? What is the probability, using this rule, what is the probability of not observing B is equal to 1 minus half, which is half. Without even drawing the outcome, without even writing down outcome. But to prove this, let's write down not observing B will be anything except these two, right? Anything except these two, which is tail, head, tail, right? And then obviously you see the outcome is, the probability of this outcome is half. Okay? So this is another probability rule. Not observing event A or B is 1 minus probability of observing that specific event. Okay, so before we talk about the last probability rule, we want to talk about disjoint event. So we have this sample space. The first event is observing head, tail, tail. The next event is H, T, H. Next event is at least one T. T, H, T, H. These are the events I have. Is there any common outcome between event A and B? Is there any common outcome between event A and B? No, right? They are not. They don't have any common outcome. Correct? If two events, they don't have any common outcome, we call them disjoint. So whenever two events don't have any common outcome, we call them disjoint. In this example, event A and B are disjoint. Correct? So do you understand the concept of disjoint? Is that clear? So now answer this question. Are event A and C disjoint?
No.
Why? Because they have at least one common outcome, which is exactly TT, right? A and C. I'm talking about A and C. They have one common outcome. So we say A and C are not disjoint, right? What about B and C? Are they disjoint? No, because TH and HT are common, exactly. So now do you understand the concept of disjoint? Okay, so the last rule of probability says if two events are disjoint, now you know what disjoint means, right? If two events are disjoint, probability of observing one event or the other event is equal to the probability of observing A plus probability of observing B. If they are disjoint. So in this question, A and B were disjoint, right? If I ask you what is the probability of observing event A or event B, probability of observing either A or B. We will say according to the last rule of probability, if A and B are disjoint, which they are, right? We can say probability of A, which is, what is the probability of A here? 1/2, right? Probability of A was 1/2. Plus, what is the probability of B? 1/2, right? And then 2/2, which is 1. Correct? So we use the last rule of probability to answer this question. If two events are disjoint, we can answer this kind of question using that last rule I talked about. Do you have any question? Is there any question? So now I want to make it clear. If I'm talking about disjoint event and my question is just this, are A and B disjoint? You will say yes. Why? Because they don't have any common outcome. To answer this kind of question, are they disjoint, you don't have to find the probability. You just look for a common outcome. That's it. Correct? So if I ask you if two events are disjoint, you will just look for a common outcome. If there is not any common outcome, they are disjoint. If there is any common outcome, they are not disjoint. Okay? Do you have any question? Let me see if I have some fast question. Right now. Okay, so let's just review this question in this 10 minutes we have. It says fake numbers in tax return, invoices, or expense account claims often display patterns that aren't present in legitimate records. Some patterns, such as too many round numbers, are obvious and easily avoided by a clever proof. Others are more subtle. It's a striking fact that the first digits of numbers in legitimate records often follow a model known as Benford law. Called the first digit of a randomly chosen record X for sure. And Benford law gives the probability model for X in this way. So to observe random digit 1, we have this probability. To observe random digit 2, we have other probability, and up to observing none. Okay? So the second row is probability, the first row is observing a specific number. It says the probability that the first digit is equal or greater than 6. So we consider this probability because this is equal to 6, right? Up to all the number greater than 6. And we know these numbers are disjoint. Correct? They are not related. So what we do, we add probability of observing 6 plus probability of observing 7 plus probability of observing 8 plus probability of observing 9. But if they were talking about probability of observing any number greater than 6, and they were not including 6, so we wouldn't add probability of observing 6, right? We would start with probability of observing 7 up to 9. So what is the probability of observing 2? So it's obvious, yes? 0.176. And if I ask you what is the probability of observing any digit between 2 and 4, 2 and 4 is not included. So what you would say? 1 to 5, right? Because I said any number between 2 and 4. 2 and 4 are not included, right? So you would just choose observing 3, correct? And then what is the probability of observing any number except 1? How you find that? Add all the numbers from 2 up to 9, subtract that from 1, right? That would be probability of observing any number except 1 using this law, right? Okay. Do you have any questions so far? For now, I think that is kind of enough. And we almost talked about everything in this chapter. Oh, look at the random variable. It says a random variable is a variable whose value is a numerical outcome of a random phenomenon. And then the probability distribution of a random variable x tells us what values x can take and how to assign probability to these values. So this chart you saw here, this one is probability distribution, because for each of these number digits you see, you have a probability assigned, right? So all this thing is probability distribution according to this definition. Okay, any questions? Okay, so I will see you on Monday, and we will continue solving more probability questions, something similar to whatever you see on the exam. And if we have more time, we will start chapter 15 also. Okay? Take care. See you on Monday. Did you bring your exam paper?
Are you taking women nutrition right now?
Yeah.
Is that online?
I don't know. I did it in the class.
Here?
Yeah.
In the fall.
I'm taking it now.
Oh, is it, how is it simply?
What are you talking about? The human nutrition? Oh, no. I'm taking it next semester. I might not be here next semester.
Are you saying are you at school or no?
Did you finish chemistry?
Are you gonna go to the gym?
Check my answers.
Because I'm gonna go to the.
Are you doing the micro? Are you doing the cal right now? Cash?
Yeah.
I'll go there.
Okay.
Are you doing micro right now?
I don't know.
Micro? Next semester.
Did you compare others? Everything is right?
So you're doing the DSM, right?
Huh? Yeah.
No, I just want to
Do
see
you have enough
why.
money?
I have money there.
Like the check.
Bibliography?
You have enough qualifying months? Remaining?
Oh, okay.
Wait, annotated?
Because I did I already did all of these while I was in the military.
Oh.
I want to tell you right now.
After this semester, I'll apply for the fall. But I gotta take like 3 classes this summer though.
Oh, can you
Next
stop that?
semester I can take microbiology.
Thank you.
Nutrition.